Okay. So now we do the series. All sections we just did, they were about sequences, and then these two sections are about a thing we call series, which we will define, and we'll get back to this slide at the end of the lesson. Right? A sequence is an ordered list of numbers. A series is the sum of a sequence. So this is an example of a finite sequence. It's arithmetic sequence. 6, 9, 12, 15, and 18. The series part of it would be add them up. That's what we mean by series. Now, can you add up 6 plus 9 plus 12 plus 15 plus 18? Sure, I mean, it's 5 numbers. Wouldn't be that hard. You add them up. Okay, but we could do that because it's finite. There's a certain number of terms, we can add them up. If you have an infinite sequence and you try to make that into an infinite series, right, then can you add that up? Well, just imagine every time in an arithmetic sequence, every time you go to the next term and you try to add that, it's going to change the sum. So are we going to have like one fixed value for the sum? No. So you can't add up infinite arithmetic sequences or series, right? You just can't do it. Because it doesn't, what we call, and what you'll see later, would do what we call converge to a sum. So we can add up finite arithmetic sequences. Did anybody add this up? You know how you would add it up? I mean, because you keep adding 3, right? There's 5 terms. It must be that 6 plus 18 divided by 2 is the middle number, right? And 9 plus 15 divided by 2 is the middle number. So in fact, it should be 5 times 12, 60. Now you could do it individually, but it is 5 times 12. Right, so the folklore is that Gauss, who's a really famous mathematician, he comes up with the normal curve and a lot of other things. When he was like 5th grade, 6th grade, the teacher says, okay, everybody add up all the numbers from 1 to 100. And the teacher thought, okay, all these little German kids are going to be busy for the next hour. I can do something else. But he kind of instinctively knew that thing. If you add up the first term and the last term, and then multiply it by the number of terms divided by 2, or take the average of those two and multiply it by the number of terms, it's going to be the same thing. I don't know whether that's true, but that is a story that most textbooks, right besides where they give you that story, the fable of Gauss. Now, there's 3 things. The sum is represented by the capital S, right? The n means this is a finite sum. There is going to be a certain number of terms that we are adding up here. Okay. The n in the formula here, right, that represents the number of terms. And I think we know what the A1 represents, right? That's the first term. And if you can imagine, I mean, it says A sub n, but if we know what the n is, then actually the A sub n is the last term. Right? If I'm finding the sum of 20 terms, n is 20, then that's A20. It's the last term. So these are the 3 things. So you need 3 inputs to the formula for the finite sum. And pre-cal, which has almost identical content in this stuff, first they had the formula was given to them. Second, they had 2 problems where they actually used the formula, word problem kind of things, and they had to use the formula. Next, it was a true-false question. True or false, if all you know is the first term and the last term, you can add up a finite arithmetic sequence or series. If all you know is this and this, you can add them up. Is that true or false? Because what else do you need? The number of terms. They almost all got it wrong. I mean, they'd actually used the formula. They had it, they'd used it, but then in a true-false question, couldn't get that part of it right. Okay. So now we're going to use that formula, add up some finite arithmetic. This is a kind of a question you might see on an SAT. Right? And when they say that kind of thing, I mean, besides the fact that it's from 2 to 100, they're telling you the integers. And you got to know what they mean by that. You can't be stumped on, oh, what do they mean by integer? And the integers are the plus and minus whole numbers, right? In this case, they said go from 2 to 100. So let's see. We need 3 inputs to that formula. We need the first term, the last term, and the number of terms. Okay, the 2 is the first term. The 100 is the last term. How many terms do you think there's going to be if it's the even numbers, 2 to 100? 50. The even numbers from 2 to 100, right? So this is going to be 50. So I'll just write it up. S50 equals 50 divided by 2 times 2 plus 100, right? It's the first term plus the last term times n over 2. So this is 25 times 102. Which is what? 2550? 2550? Too easy, right? I mean, the thing, you're given these formulas. And in a math class, if you're given the formulas, all you have to know is how to use them, then you better learn how to use them. Okay. I mean, there's really no excuse when you've got the formula right in front of you, being able to use it. It doesn't get any easier than that. So try to do the same thing with this one, right? This is a you try. It's the numbers from 4 to 99. I actually added this 20 terms thing here because it was not in the book problem. But you should be able to figure out everything you need that goes into that formula. See what it is. Who's got it? You always answer, Curtis. Okay, change. 1030. 1030. Okay. So let's see. S, there's 20 terms, equals 20 over 2 times 4 plus 99, which is 10 times 103. Now, like I said, truthfully, in this problem, the book didn't have that. Watch this. I'm going to go right. That was not, the 20 terms was not in there. So how would you have found out the number of terms if they didn't tell you the number of terms? Well, I mean, what if it's, 10,099? You going to do that? What you're really supposed to do is use your formula for AN. Right? If you have a formula for AN equals A1 plus N minus 1 times D, right? The one we learned for the sequence. You could see the first term, you can see the D, right? So you plug that in, 4 plus n minus 1 times 5, which was the common difference. And you could, the last term was actually 99. So solve for n. That's how you would find it. If you didn't know the number of terms, then use that formula, set it equal to the last term, solve for n. That's where the 20 comes from. And I'm finding in this lesson, because I did it with the Algebra 2 in the fifth block today, that, and this is the first time through this book, since there's a new book this year, they've really changed it a lot in the way they present these, because that was never something that they would have done last year. To expect on the very first example that we actually don't know the number of terms. But, I mean, is it fair? Yeah, it's a fair question. Okay, how about this one? Find the sum of the first 20 terms. Now, looking at that sequence and then knowing our formula, right? Sn equals n over 2 times a1 plus an. I know 2 out of the 3 inputs, but I'm missing 1, right? Which is the thing that I'm missing? You don't know the last term, right? So how are you going to find the last term so you can plug it into the formula? You're going to have to either do this, right? Use the formula and just calculate. Right? You can plug in, you can see what the A1 is. You can see that the D is 4. And it's 20 terms, so you know what the N is. So you plug in all of that, and you get your AN, which you can plug in there. But another thing you can do, and actually on the formula sheet that you're given, they've done this. Instead of doing that every time, like it's an individual project to be done, that instead we're going to substitute this formula here for A sub n, and then simplify. Right? Sn equals n over 2 times a1 plus, and now in place of the an, I'm going to put a1 plus n minus 1 times d. And there's a little simplifying you can do, right? a1 plus a1 is 2a1. Sn equals n over 2 times 2a1 plus n minus 1 times d. So that's a version of this. This is the explicit formula, but this is kind of a version of it if you don't know the last term, that you could use that. And you don't need the last term anymore. All you need are the number of terms, the first term, and the common difference instead. But if you want, you can definitely plug into this and find that. Yeah.
So, was there ever been a case where it's like, so they gave me the numbers like 100 and 94 and like 88, and like the dot 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 or whatever is going to the 88 back? Like, will you ever have to find the 88?
I mean, you could. They don't really do that in this class. In pre-cal, we might do a thing like that. I mean, but you could be explaining a sequence like this, right? Where the terms start there and go, they just start at 100 and they go down. But could they give you this, you know, in the order where you've got whatever these are, 113, 109, 105, dot, 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 find the first term. Sure. Well, it's not really quite fair to say that, though, because like this, they would have to tell you if it went like this, if you had 194, is that what you said? And then 90 and 88, and it said find the first term. You would have to know for one of these, which term is that? I mean, is this supposedly the 20th term? Because otherwise you wouldn't know how many times to go backwards with 6, the common difference, before you stopped. Because there's no telling that it actually starts at 1. It could be negative numbers. It could be anything. Well, yeah, they could do that. I haven't seen that, but that's fine. So let's do this one here. Find the sum of the first 20 terms. And I'm going to plug it into this formula. And that would be S20 is 20 over 2 times 2 times A1, which is 1, plus n minus 1. Well, the n is 20, so that's 20 minus 1, times the common difference, which was 4. Okay. There we go. So that is 10 times 2 plus 19 times 4, which is 76. 10 plus, or sorry, that was wrong. Edit. Undo. Edit, undo. 10 times 78. 780. So that you're given these two formulas on the sheet, on the SOL sheet, for the finite sum. And that's why, in case you don't know the last term, you might find it more convenient to use that, because you don't need it then. Okay, now, where this starts to get more, let's just say, abstract, is we introduce a new kind of notation, which is called summation notation or sigma notation. Most of the time I've seen it called sigma, but it is a summation, and the SOL will say summation. But it has this, is a capital Greek letter sigma. And you could see underneath this particular example, it says n equals 1 underneath, and then it has a 5 on the top, and it has a formula, n squared, in front of it. Now, I'm telling you that that summation generated all of these terms to be added up. So can you imagine how that works? Where did the first term come from? What's that? Yeah, we took the 1 and we plugged it into that formula. That was the first term. Okay. Where did the last term come from? From the top, right? Where did the terms in the middle come from? They're all the numbers in between the bottom number and the top number. And that's how it works. You plug in the bottom number, and then you add 1 and plug in that number. And then you add 1 and plug in that number until you get to the top. Yes?
So if on the bottom it said n equals 2, you would go by 2?
No, you go by 1s, but you would start with n equals 2. It's always increments by 1. Okay? So this Greek letter, that is called sigma. Okay? The n here is called the index. The number on the bottom is called the lower limit. And the number on the top is called the upper limit. Right, those are the parts of a summation notation. And you could see this n squared is making this sequence of numbers, 1, 4, 9, 16, 25. Is that arithmetic? Is this sequence of numbers arithmetic? No. Is it geometric? Really? 4 times 1 is 4. 4 times 4 is 16, and that's all right. So it's neither. So when you get asked this kind of a question, and it's not arithmetic and it's not geometric, all you can really do is make the terms and add them up. So you do that. We're going to come up with formulas for arithmetic and geometric. I mean, that's most of what the lesson is today. We have formulas for this. But if you don't have a formula, all you can do is just make the terms, add them up. If the only kind of questions you're going to get like that, it's going to be not too many terms. I mean, they can't have you adding up 100 terms that you've got to make every one by hand. Okay. And again, this is another example where their problems, I did not notice as they put this in, but it's more difficult than you think. Here's a arithmetic sequence. It starts at 7 and it goes to 27. It said make the summation notation, meaning let's rewrite that with the Greek symbol. And although the Greek symbol is pretty close to what I did on the last slide, I'm not going to take so much effort every time. I usually just go something like that. You know, if you have to do a whole bunch of these things, you're not going to make the little hooks on the end of it every time. So there it is. So in order for this to be summation notation, I need to go from n equals, and it honestly does not have to start with 1, but if you're making it yourself, you're probably going to start it at 1. You need to figure out what is the number that goes on top, which would be how many terms there are, and what is the formula that goes here. Well, this is an arithmetic sequence, so how can we come up with a formula for it? Trevor? You were saying something or no? How can I find a sub n for an arithmetic? We got a formula for that, right? The same one we used in the homework last night. That's it. So we're going to say an equals a1 plus n minus 1 times d. And we can plug in for the only two things we need, the first term and the common difference. You can see them right there, right? The first term is 7, the d is 4. So plug that in here. An equals 7 plus n minus 1 times 4. An equals 7 plus 4n minus 4. An equals 4n plus 3. So there's the a sub n. That's what will go here. But now we need to know how many terms are we adding up. How can we figure that out? I mean, basically, which term in the sequence is that? So we know it's the last term, but is it the 10th, the 20th, the 30th? We need that number to go on the top so we know how many terms this is. Yeah, put it in this right here, right? You just came up with this formula. Put the 207 on the left and solve for n. That'll be the n that goes on the top. Right? So that is 207 equals 4n plus 3. 204 equals 4n. So n equals 51. Right? And that goes here. So here it is. The sum from n equals 1 to 51 of 4n plus 3. Now, you can always test your formulas out to make sure that they work. I mean, it should be that when I plug in the lower limit, I get the first term. So let's try it. If I put in a 1, I get 4 times 1 plus 3, 7. Works. Okay, it should be that if I plug in the upper limit, then I get the last term. So let's try it. 4 times 51, 204, plus 3, 207. So it works. This would generate 51 terms, starting at 7, ending at 207. Now, they did not ask us to add it up. They just said, write it in summation notation. So try to put that one in summation notation. Doing the same thing. Right? You need a formula for an. You need to know how many terms is that. Everybody get a formula? What's that? I just clear memory. What was the formula? Who's got a formula for me? Shane? The A sub n. Yeah. 7n minus 12. Is that it? He's saying 7n minus 12. Does that sound right? Okay, let's see. So for at least for the first term, 7 times 1 minus 12 would be negative 5, so that works. Okay. Now, before we can check the rest of it, right, we need to know how many terms are there. Did anybody figure that out? Again, how were we going to figure that out? Set this 268 equal to the 7n minus 12, right? And solve that for n. That'll tell you what the number is that goes on the top. You use an equals a1 plus n minus 1 times d. And you plug in the first term, which is negative 5, and the common difference, which appears to be 7. And you simplify. Okay. You got to start somewhere. Right? You're going to start by plugging in the lower limit, and then you're going to end when you get to the upper limit. So do you have to start there? No, you don't have to. You could start at 0 if you want. But if I did 0, then 7 times 0 minus 12 would not be our first term. We'd have to recalculate our formula. Probably better to use 1 if you have a choice. But if you solve this here, you're going to get 280 equals 7n, so n equals 40. So that is 40. So that's the summation notation. Okay. Now we're not just, we have a summation. We're going to try to add them up. Okay. So n equals 1 to 70, 5n plus 3. Looking at that there, can you tell whether it's arithmetic? Remember, in arithmetic sequence, the formula looks linear, right? It should be the n to the first power, kind of like a mx plus b or a mn plus b. Yeah, that's exactly what you've got. So when you have a formula like that, you know you're dealing with an arithmetic sequence. So we can use our formula, Sn equals n over 2 a1 plus an. They didn't say that was arithmetic, but we recognize it because it's got a linear format to it. Okay, now I need 3 things to plug in. The number of terms, the first term, and the last term. How many terms am I going to be generating if it starts at 1 and it ends at 70? 70, right? So n equals 70. Right. How are we going to find the first term? If I was going to make 70 terms, what is the first thing I would do? You would put in the 1, right? So putting in the 1, I get the first term. Right? How am I going to find the last term? What is the last thing that I'm going to do? Plug in the 70. That's how you're going to find the last term. Okay, well, the first term should be A1 equals 5 times 1 plus 3, which is 8. And the last term will be 5 times 70 plus 3, which is 353. Okay, so that's everything you need to plug into that formula, right? Plug in for n, S70 equals 70 divided by 2 times A1, which is 8, plus AN, or A70, which is 353. So equals 35 times 361. And what is that? 12,635? Sounds about right. Did you have a question, Shane? Or you're just offering that up? Okay. So again, if you have the summation notation, that's what you're going to do, right? Just find the first term, the last term, and the number of terms. Now, is it always the case that whatever the number is on top of the summation is the number of terms? No. What if this thing instead had been the sum of n equals 2 to 70? Would that be 70 terms? No, it would be 69 because you didn't start at 1. So in general, if it doesn't start at 1, then what you have to do is go 70 minus that number plus 1. Right? 70 minus 2 is 68, plus 1 is 69. Just like this, 70 minus 1 is 69. And that's not the number of terms. It's actually one more. So be on the lookout for indexes, the lower limit, that don't start at 1. Right? You're still going to find the first term by plugging in whatever that bottom number is. That's how you find the first term. Even if it's not 1, that's how you find it. And this is the last term. Now, does that look like it could be arithmetic? Does that look like a linear mx plus b kind of thing? No. So you can't use that formula for that. But there's not that many terms, so you could generate all those terms, plug in 1, 2, 3, 4, 5, 6, 7, add them all up. But this would be a good place to show you that, in fact, your calculator does this for you. So take out your calculator. So there's a couple different ways you can get at it there. But generally, this is a useful menu for you to know where to find it, which is alpha window. Right? If you hit alpha window, it brings up some of the more used functions, including the absolute value is first, the summation is second, and the log base, the log of any base, is the last. The other two are calculus things. But if we go alpha window 2, and then we get our summation notation right there. Okay. So now you can use n or x or whatever. Just make sure that whatever your index is here is the variable that you're using here. Alpha window 2. Or you can go math, and you can scroll to the bottom of the menu, and you find it there too. Summation. So let's say we use the n. Where's the n? I can't read it here. I think it's on the hat, the caret. Oh, it's over here. Okay, that's right. Okay, so I go alpha n. No, that was wrong. You told me alpha n. Okay, and now I go scroll over here. That'll be 1. Do this again. Second. You know, it kind of does it itself. Like when I hit 1, it jumps to the top, I think. Doesn't it? No, it didn't. Okay, now we put in the 7. And now here's an important part. If you're going to do this, you need the whole formula inside those parentheses. It's not n minus 1, and then you put the square on the outside of those parentheses. Because then it's going to find the sum of the n minus 1s, and it's going to square it. You don't want that. So make sure that you're going to use another set of parentheses. Parenthesis, alpha above log, as you say. Okay, minus 1. Okay, none, end the parenthesis, and square it. Right, that square needs to be inside those parentheses for the summation, or else it won't do it right. But now it's going to add up that formula. Ready? 91. You could use X if you want. And that, honestly, that's what I would do. But if you're hung up on the N, you could definitely use N. Whatever, just make sure that in like one position you don't put an N, and the other one you put an X. Now that's going to mess up on you. Right? Make sure you use the same variable. So I can tell you that, let's say I put something like this on a test, right? Well, anybody who knows how to use the summation notation is just going to go to the calculator. I'm more likely to give you this and say, tell me how many terms, what's the first term, and what's the last term, and not ask you for the sum, because I know you can just put that in the calculator without much thinking. But I would like to just, tell me those things you get out of that. So didn't we just do that? Oh, I didn't actually write on the screen, did I? So from the calculator, that one was 91. Okay, so tell me the first term, the last term, and the number of terms, and then find the sum. Yeah.
So, if they're just asking for the sum and not like the first term,
Right.
can we just put it in a calculator?
If I don't tell you not to, unless they say no calculators or something like that. The pre-cal kids are going to get a test back tomorrow, which they did horrible on. Horrible, right? And it says, on some of it says, give the exact answer of this, and then parentheses says, no decimals, no calculator. And then their answers are like all decimals. It's like, I don't know how more clear I can be about this. No decimals, no calculator. I guess that the next time we just won't have calculators. Just take away the calculators, because they just can't resist putting them in. It says right there, no calculators, no decimals. Now, your sister's not one of the ones who did that. There was two that really excelled, and she was one. Okay, what was the number of terms? 40. Okay, what is the first term? -5. And what is the last term? 112. Right, just so the first term, plug in 1. Last term, plug in 40. Now, all that stuff you can put in the calculator. Or sorry, you could put in the formula. SN, I'm not even going to do that. Edit, undo. I'm just going to say S40 equals, equals 40 over 2 times -5 plus 112. And what does that equal? Chad? 2140? Has everybody agreed with 2140? Okay. Let's vote on it. We agree that that equals 2140. Okay. Resolution passes. Okay. Now, for geometric, we got another formula, and that's the formula. Again, all these are given to you. You don't have to remember it. You have to just know how to use it. And you can see what the parts of the formula are. You need to know the first term, you need to know the common ratio, and you need to know the number of terms. You actually don't need to know the last term, which could be a little bit of an advantage. Okay, so let's add these up using the formula, right? I mean, if you have the summation notation, you can obviously use that, but it's not in summation notation. You're going to have to peel out this information and figure it out. Now, what things can I identify from that sequence? The first term, 3. The R, what does it look like we're doing to go to each term? Looks like you're multiplying times 2. So again, the last thing that they did, and this is a particular problem in this one, which is you don't know how many terms there are. You know, what term in the sequence is that? And how are you going to figure that out? Again, you're going to have to use the formula for an and then solve for the n. And it's not that easy, right? So this one here will be, remember, an for geometric is a1 times r to the n minus 1. And we know what the a1 is, and we know what the r is, and we know the value of the last term. So we can fill all of that in. 3072 equals 3 times 2 to the n minus 1. Solve for n. How would I solve that for n? How about divide by 3? Yes. That's what a question sounds like. How do you solve for n? Right? Divide 3. Divide 3. 1024 equals 2 to the n minus 1. All right, well, this would be hard for us to solve unless 1024 is actually a power of 2. Let's see. Divide 1024 by 2. What do you get? 512. Divide 512 by 2. 256. Divide 256 by 2. 128. 64. Yeah, these are all powers of 2. So we can figure out how many times is it you multiply 2 before you get to 1024. Anybody? Just try one. So let me go 2 to the 10th just for fun. 2 hat 10. 1024. So actually 1024 is 2 to the 10th. So if on this thing here, I'm going to say 2 to the 10th equals 2 to the n minus 1. So what does n equal? N is 11. N is 11. Okay. So if n is 11, then we know everything we need to plug in this formula. S11 equals A1, which is 3, times, where am I at? 1 minus 2 to the 11th divided by 1 minus 2. Now, we make a lot of mistakes, even if we get this far and you've got everything entered in the right spot, okay? But you can help yourself a lot if you remember in the calculator how to bring up the fraction format. Do you remember where that is? Alpha y equals 1. So it'd help to use that. I mean, you don't need as many parentheses if you do it that way. So it'd be 3 times 1 minus 2 hat 11. Get out of the right parenthesis, divided by, that was wrong. We got to arrow down, 1 minus 2. Does that look right? It does, so enter. 6141. Now, it helps to have the fraction format. The other place where you might run into trouble is, what if the r was negative? Then you got to be careful with this minus r, being raised to a power. You're going to have to put the r, the negative number, in parentheses before you raise it to a power. That's a common place to make a mistake. So 6141. So what do you think is next? Before we get to that, so here's a summation, but this time it's in that notation. Now, if you know how to put it in the calculator and that's all it's asking for, then you can put it in the calculator and figure it out. If you don't know how to do that, or if you're being asked in a way where you're really going to have to do this, then you have to be able to figure out what is the A1 and what is the R and what is the N from this right here, right? And the easy thing, let's say, is the R, right? When you see the formula like that, which looks kind of exponential because that's what geometric looks like, R is whatever is being raised to a power. So it's 1/2. R is whatever is being raised to a power. That's why when you increment the N by 1, you get one more factor of whatever the R is, right? So there's the R. The number of terms, not too hard. How many terms are there in this one? Incorrect. 21. It started at 0, ended at 20. That's not 20, right? That's 21. So N equals 21. And then how are you going to find the first term? Plug in the lower limit, right? So plug in that 0 here. And what will that be? A1 equals 4 times 1/2 to the 0. What is 4 times 1/2 to the 0? It's 4, because anything to the 0 is 1, so that's 4. So now you know everything you need to plug into that formula. So that would be S21 equals 4 times 1 minus 1/2 to the, what did we say, 21? Divided by 1 minus 1/2. So again, if you're going to put this in the calculator with a 1/2 and not a 0.5, you need to have the 1/2 in parentheses. Okay. Otherwise, it's going to go 1 divided by 2 to the 21st, which actually in this case may work because that's a 1 to the 21st would be the same thing. So you could do that, or if you got it in the summation notation, then that actually goes directly into the calculator like it is. So I should finish this anyways. So this will be alpha y equals 1, 4 times 1 minus 0.5 raised to the 21. Get out of that. Arrow down. 1 minus 0.5. Look good? Get better. 7.99999. How about we'll round it to 8? Okay. So I think the U try, is that it? The U try is this. So we need to know what is the sum. Now, this is actually an easy one, right? You could see the first term. You could tell the R pretty quickly. And you could count the number of terms. So see if you can find the sum using the formula. I know this one is one that's be just as easy just to add them up because it's so little numbers. Make sure you got that negative 2 in parentheses. Should get 315. Count the terms. 1, 2, 3, 4, 5, 6. And that's kind of, I mean, if you didn't get that, if you tried to do this as a formula and you didn't get that, most likely you didn't have the negative 2 in parentheses. And that would have changed things. Okay, last concept. I think we're not going to do that. We just don't have enough time. So we already did how to calculate with the calculator. And before I go into this here, let me just explain this. In this formula, in this summation here, what is R? It's 1/2. R is whatever is being raised to a power. So take, for example, if I was going to walk, let's say that this board from the left side to the right side to the left side is 1 long, right? And I'm going to walk in steps halfway to the end with each step. So the first step, I go here, right? I'm halfway there. Next, I go halfway to the end. So I'm here, right? Next, I go halfway to the end. In each step, I go halfway to the end. Do I ever get to the end? No, I never get to the end. But I get so close, infinitely close. It's like a line approaching an asymptote. And so we would say that the sum is converging to whatever this distance is, in this case 1. Does it ever quite get there? Not quite, but we're going to say it's converging to 1. So that works whenever the R is less than 1. If R is less than 1, if the terms are getting smaller in a geometric sequence only, then it will converge to a sum. And I was trying to do this different. I did it in the first block, and like with you guys, it's getting kind of long, this lesson. But, you know, just showing that if you do the sum of 1 to 5, 1 to 6, 1 to 7, 1 to 8, it keeps getting closer and closer and closer to a number, right? But anyways, so you might as well just say the sum of 1 to infinity, because it's not changing as it goes up as the upper limit increases. It just doesn't change. So we can take the sum, we can do an infinite sum for a geometric series. That's the formula right there. Okay. Now you can't always do it. Remember, what did I say about the terms in order for this to work? They got to be getting smaller. And the way that you make sure that they're getting smaller is that the absolute value of R is less than 1. Meaning they could be flipping signs, but they've got to be getting smaller in magnitude. As long as that's the case, then that's the formula. It's actually an easier formula, because you don't need the number of terms anymore. There's an infinite number of terms. Now, on the SOL formula sheet, they actually go like this: S infinity. I've never seen that before. I've always just seen it without any subscript. So if you don't see a subscript, it means infinity. If you see an infinity, it's infinity. So again, what we're going to have to check is the R less than 1, or are the terms getting smaller? If either one of those are true, then you're going to use that formula. Okay, how about this one? Are the terms getting smaller? Yes, they are. What does it look like as the R? 1/2, right? So here's the formula. S equals A1 over 1 minus R. The A1 you can see, and the R is 1/2. So plug that in. 1 over 1 minus 1/2, which is 1 over 1/2, which is 2. And if you do it, if you put that in the calculator, make sure that's in parentheses or using that fraction bar, right? How about that one? Is the absolute value of R less than 1? What is R? What?
No, it's the negative 5.
It's
Which it is smaller than 1.
the absolute value.
Oh, the absolute value. Should know it's not bigger.
Yeah, the absolute value of this thing is greater than 1. So this does not converge, no sum, stop. There's nothing to do. Okay. This is the R, right? The absolute value of negative 5/4 equals 5/4, which is greater than 1. So no, you can't do that. No, the way you either you say no sum or it doesn't converge. So there's nothing to do on that. Okay. So which one of these would not converge? That the terms are getting bigger, or the R is greater than 1. You could clearly this one, the R is less than 1, so that's okay. These are getting smaller, that's getting bigger, right? So this one, no sum, right? And this one, what is the R? 1/3? Negative 1/3, because they keep flipping signs. So this one you would have to use R is negative 1/3. And the A1 is there. Okay, let's say you wanted to put that in the calculator. Hey, it's a summation notation, right? Let's use the summation notation in the calculator and do it. So that's, you bring up the calculator. Come on, don't mess up with me. Okay, clear. So let's go alpha, window, 2. And I'm going to just use X. X equals 1. Okay, now where's the infinity symbol in the calculator? No, there's no infinity symbol in the calculator. Okay, that's the thing. There is no infinity symbol in the calculator. So what you can do is you could put in a big number, and it'll still do infinity. They converge pretty quickly. So if you put in a big number, just don't be ridiculous with it. If you put in a 1,000, it's going to be thinking for 15 minutes, right? So you don't want to do that. Use 50. You know, if I put in a number like 50, and then I go ahead and put my formula in, which is 2/3 to the n. So remember, all that needs to go inside. So I'm going to parentheses 2 divided by 3, n parenthesis, raised to the x, because I use x. Enter. And what do you think it's converging to? 2. Okay, so you don't have an infinity. We were in a mandatory meeting the other day with other teachers, and not everybody knew how to do that. They were kind of shocked. Really? Really, it works. Right, so this one is converging to 2. Okay, so now we know distinguishing a sequence and a series. I think we can do that. Use and interpret summation notation. Right? Given formulas, write the first n terms and find the sum. Okay, find Sn for the first n terms of arithmetic and geometric. Given a formula, find the sum of a convergent infinite series. And model real-world situations. I'm not sure if you got a problem in the homework like that. That is the homework.